So I have already uploaded it in the Pandas example folder, and also, so you can download this notebook and the flight dataset. So, all this was covered yesterday. So when we're looking at the underlying structure of the data, you see, when we're calling such descriptive statistics, we now know what's the count, what's the average, etc. So all this is part of exploratory data analysis. It's done to have more insight into the data that we'll be working with. It involves mainly the use of plots because it's meant to be quick, You have to display the data in something you can see at a glance. For instance, you see, when we're grouping by, we now know how many females, males, etc. The distribution. When we're now plotting, we see how the salary is distributed. You see, so this is all part of exploratory data analysis. Do we have any questions so far from what we did yesterday?
No question.
Okay, yes.
Hello, Bill.
Hello?
Yes, maybe can you show us how to add a row on a data frame? A row in the column.
You want to? Okay. I think, yeah, I'll do that.
All right, thanks.
All right. Okay, so you remember when I was mentioning detecting outliers in your data, and I talked about these box plots. Distribution, we have there's density plots, which show us whether the data is normally distributed or not. This shows, the box plot shows mainly the 5-number summary, minimum, maximum, median, and the 25 percentile and 75 percentile. Yeah, if you remember from what we talked about yesterday, this part would be the 25 percentile, the median, 75 percentile. Points above these two reflect the outliers in the data set. So, now where we were at yesterday, oh yes, we were now here. So, you remember this link was not working. So I had to download the data from a different source. And the first stage was reading this data set into a Pandas data frame. So, with Pandas, you remember from yesterday, if you press Shift Tab, you can choose, you can see all the arguments that go into a particular function or a particular method. So, Pandas has an argument. The read CSV has an argument, use calls. So what this argument does is, it you tell it which columns to use. there were like unnecessary columns in the data set. So I did not want to include those. So, okay, let me do this. If I read it like this, right? Let's go ahead. You see, those columns are largely empty. They do not contain much. So you see, out of 100,000, they have 80,000 missing values. This one has 98,858 to include them for our analysis. So if find the columns, I can slice the shape. For instance, if I want it to show just the columns, I can slice it 0. That's for the rows. That's for the columns. It uses the same index notation, whereby if you use square brackets and this is index 0, this is index 1, you can then choose a particular element. So, since we looked at most of the plotting yesterday, I'll just move on to missing values. One thing you realize in the real world, you won't ever find perfect data. You'll find it contains some mistakes. Sometimes you find it contains missing values. So the object of this section, the aim is to equip you with the relevant skills to deal with. So, you see, if I call is now, it gives me a list of each column saying false for wherever there is no missing value, and it returns true for wherever there is a missing value. So in Python, false is represented by a 0 and true is represented by a 1. So it means all these places without missing values, it's false, so there are zeros. Then places with missing values, it's true, which means there are ones. So I can then use that knowledge to sum up all the ones in the column, and voila, this is what I get. Year contains 0 missing values, month contains 0, departure time contains 1,142 and the like. Are we together so far?
Yes.
Yes.
Okay. So here, select rows that have at least one missing value. So you see, now we're looking at flights.isNow. You saw that this part of the code returns a true or a false, right? True or false. So when I filter like this, what happens is forever the value holds true, that row will be returned. And if it's false, the row will be ignored. So if I filter like this, I then have something like this, where a row contains at least one missing value. See, in every row, you're finding that there is at least one missing value. Okay. Yeah, I was just looking at the columns in our data set. So the opposite of is now is not now. Makambona Python chinoita ngori kutongoverenga chirungu. It's either something is now or it's not now. So when we filter using not now, what is returned is a data frame with no missing values. In this instance, what we did was we looked at one column, arrival delay, right? And we said, just return all the rows where arrival delay has no missing values. So other columns may contain, but this particular column should not contain missing values. So that's what our flight one is. So if we are to look at it, we run it. If we are to look at it, flight one, which is now some. So when you now look at it, we have no missing values in flight one. Reason being, wherever arrival delay was missing, then that's where we would find all other missing values. So missing values would occur in arrival delay and the other columns. So from the get-go, you see origin contains nothing. So this would return nothing. So it's just an empty data frame, as you can see. So we are now changing flight one. This time we're now including only the parts where arrival delay is missing. See? It's now the opposite of what we had. So this is just the first 10 rows of missing values. Then I bring you to how specific ways you can handle missing values. One, we can handle missing values by ensuring that we can drop them. Right. So like in this case, flight 3, we say it drop now, meaning drop all the missing values. So you see, flight 3 now has no missing values. When we now check if there are any missing values in flight 3, we can use this. And it returns nothing. Another way of dealing with missing values is, because in most instances, those missing values, maybe they exist in less relevant columns, and or they are so significant in number such that dropping everything with a missing value would leave you with a significantly smaller data set. So what you do is dropping ceases to be an option. You now have to fill it with another value. So in this instance, we are filling no miss, departure delay. We are now filling it with zeros. We are not dropping the rows, but we are filling them with another figure. So you see, where there was a missing value is now what? 0. So you can choose various ways of filling missing values. Sometimes you can use the mean. If you use the mean, it means, okay. Let me do this. Wherever there was a missing value in departure delay, it was filled in with this number. So after we run this, let me check if the code worked. Okay, it's a series. So this value was filled in row 178, 373, 399. Can you see? If we look at, we apply the same code to no miss. You see? These will be all the areas where the missing values were inputted. You see? So apparently in no miss, there were zeros already. So when we filled with zeros, some already existed. However, you see here and here. Here we filled in with the mean, and here we filled in with the zero. Can you see the difference? And the like. So, now comes the exciting part. Can you find out how many missing values there are in the departure delay? Oh, which is this? And arrival delay columns. Oh. Can you just give me the number of missing values in those two columns? How long would you need to work on that? Come on, class. Kunetha ero.
Hakunita nje.
Okay, ko vamwe. Chido, can you work it out? Is that Chido Kwerem Sandu? Manje guys makandistikira kudai ndinodzoka ndotyaka kuti pamwe zvese zvandiri kutaura hapana chiri kupinda. Okay, in that instance rega ndidzokere ndakunotangira kwekutanga tozvidzokawo kusvika ipapo until someone willingly volunteers, then we can move on. I have all the time in the world. So this is where we started off. This particular line of code, I was choosing only the columns I wanted to work with. Here we were reading the flights dataset, and this list of columns we wanted to use is the one we assigned to use calls, meaning only use these columns in the data frame. Here we're looking at the shape of our data frame. In this instance, we're counting the missing. Yes. Well, it's just I run the cells over and over again, so the numbers on my cells may be misleading. Okay. So, in this particular instance, we were counting the number of missing values in all the columns in the data frame. So the figures you see here in the series reflect the number of missing value in each corresponding column. For example, departure time is 1,142, arrival time is 1,302, etc., etc., etc. In this instance, we were filtering the data frame for only rows with at least one missing value. So if we were to look at it, this was dotted. If I'm to like see 1,302 rows, which corresponds with the maximum number of rows with missing values. Make sense?
Mm-hmm.
Okay. Now I was just looking at which columns do we have in our data set using the dot columns. Now we're now selecting only, filtering the data frame and selecting only those rows without missing values. So this is one way of dropping missing values, right? You see?
Sorry, can you come again there?
I'm just saying this is one way of dropping missing values. Ndangosarudza pese pane something. Pane missing values are included. Where pese pana none, not a number. All those points are not included in the data set.
Okay.
So this is not now. Don't confuse it with is now. Yes. As the context suggests, they are actually opposite. So here we're selecting all rows with no missing values. So this is one way of doing it. So if we look at it, you see, we now have 98,600 and 98,698. Okay. Patamboona pape pata selector only missing values. We had 1,302. Am I correct? When you add this, 100,000 rows, which
Yes.
is what was originally in the data frame. So you are now seeing how this is the opposite of how this is the opposite of the is now, selecting all those with missing values. This is how we select all those without missing values. Are we together so far?
We are following there.
Yes, we are together.
In this instance,
Yes, we
are now proving that flight 1, which contains no missing values, really has no missing values. Can you see? Number of is now.
Okay.
Right. If I am to look at it the opposite way, we have 98,698. All missing values were dropped. We together now. So, flights 2 equals to flights where origin is now. You see, it returns nothing because where was it? The very first time we checked for missing values. You see, origin originally had the 0 missing values. So if we try to select only rows where origin is now, accordingly, we get nothing. Because 0 rows. It has 0 rows with missing values. In this instance, we're now selecting all the rows where arrival delay is now, and this is what we get. So,
Hi, John. Sorry.
hi.
So in other words, you filtered out using the one in a highest number of missing values, which is R kind.
Not necessarily. What I was trying to prove is sometimes when you are working with the data, Panama columns akakosha. I cannot use, like arbitrary values in this one. So I'm not gonna a highlighter. Then use those for can I'm missing value in this particular column. Then draw, or you can to the whole data set. So in this case, coincidentally, I am the highest. They appear even I am the lowest. Lowest, highest. Wherever there's a missing value, you would know which departure, arrival, departure, delay also contain missing values. So I think I could exist in 3 rows. 2 or 3 rows. Saka drop all missing values. Not drop the highest. Then value. Pese apasisi na missing value.
Okay.
So apapana origin. When I select is now, I'm going to return nothing. Which means if I try to filter using origin, which to the origin is not now. It means kuti going to say the original data frame. In all instances, origin does not contain any missing values. So here we're selecting based on arrival delay, where all points where it is now. So when we filter out missing values to assign it to a new variable, it's as good as we have dropped missing values. Harkubatika.
Yes.
Because we now have
Is it not like you have created flight 1, which now does not have any now values? Is it so?
Yes. So when I'm now working with flight 1, it's as good as I have dropped all missing values from the original, and I'm working with a data frame with dropped missing values. Are you catching my drift?
Yeah.
Ismail.
Okay, thank you for that. So are you catching my drift? Then another way is, because it's good coding practice, if I'm testing a method, I assign it to a different variable. I can always go back to the original one.
Okay. You don't throw it away.
Yes,
Okay.
So instead yekuti ndonotanga kurana from the top ndakuno filter out, I just start using the original one and apply a different method. So flight 3, it will be the same as flight 1, where we filtered out missing values. The same number, 98,000 something. Because it was as good as having dropped missing values. This is what I was trying to emphasize. Right. So both these are ways of dropping missing values. We can filter them out, or outrightly drop them. Right. And you see, When we now run this, takutsvaga our missing values from flight 3, we don't find them. Then we have this no miss, which is equals to this instance, we are not dropping rows with missing values. We are filling in rows with missing values and we are filling them in with zeros. So when we fill them with zeros, when we now check for missing values, apasisian. Why? Because ese akazara mazero. Am I making sense?
Yes.
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 Another way, I can decide kuti I fill in a zero. If I fill with a zero, it would distort my data. Let's assume you are working with very wide ranges, zema numbers, pamwe 100,000 etc. Then uchibva watanga kufila ma 0000. It might not bring the outcome you intend. So in such an instance, you may decide to use another statistical method to input. You can use the mean or the mode. Whereby orungoti, let's assume you're dealing with age. Or not data set iri vanhu vakanyanya wanda 130. Then you just assume kuti asaka kana munhu asina isirwa age saka anenge ari pama 30 papo. You can fill it in using a mode, you can fill it in using a mean, etc. So in this instance, we were filling the data set using the mean.
Sorry, Don. I just ask you, Papa. Is it proper to and you are saying that we can use the mean or the mode?
Mean, mode, median.
Okay. How about if I just pick a random number? Will it be mathematically correct? Like let's say for the example that we are giving an age and then you don't go beside that maybe let me put 25 from now.
25. Yeah, it's like it then depends on your domain expertise. So it depends on how important that variable is to your particular model. So as long as the number does not create outliers, you can fill it in with a number. Say zvaitaita pana 0 otonyora 25.
All right, okay, thank you.
Fill it in with some measure. Such as a mean or an ingredient. For instance, by age, also nyori 300, but no so not angari between these ages, etc.
Okay, all right, thank you.
Okay. We are back again. I'm ready to answer this. Can I not kumsoro?
Let me give it a try.
Okay, thank you.
It's unfortunate that I don't have my machine out of coded, but then let me try the number and so.
Okay.
All right. So it's delay and then we put in a square bracket. And then
okay. So Marty flights, right? I put a square bracket.
A and then departure delay.
Okay.
So we can put flight. And we are doing for departure delay.
Departure delay and arrival delay.
All right. So in Indian Chita 1-1 now. So I done for departure delay, whereby we are now saying with the departure delay, and then dot is now, and then my brackets, and then any axis. So for particularly any axis, it takes either the rows or the column. And so we are defining with any axis that is 0, that is a now value. That's the one that you need to pick up. Yes.
NX.
And then mukati mema-brackets tokuisa x is equals to 1. And then tovata close our bracket, and then we also close the square bracket.
Apa wambochiti izvito zvita square bracket rakavharwa nakare, except if you're saying I was supposed to put in 2 square brackets, which should be something like this, unless if you were suggesting
Okay. What in mind? All right, it's fine. Let's try.
still. I like the way you think. Watongorova filtering. So, let me try to add on to your method.
Okay.
A single square bracket. Let's try using 2. So what does this give us? 2 columns. What does this give us? A true number, false I. But what I want is the count. Then the method you were suggesting, so you were talking about something like this, right?
Yes.
So takachinja umu toisa ningrekeni. Arrival delay. It will still work the same way. So yeah, was that too difficult, guys? Yes. Oh, okay. Well, I deleted the cell. Yes, here it is. if I do what? It will throw an error. Unless I use double square brackets. For it to work the way you want it to work, I would have to put something like this. However, I won't be able to use shape now, because if I use shape, it will give me the sum of, it will give me the total number. It will probably give me 1302, if I'm not mistaken. 100,000, the shape of all the rows. So what is now? It will now give me the shape of where there's two columns contain missing values. It won't work. Okay. Yeah. So that's the beauty of the Jupyter Notebook. You can play around. So I thought you guys were going to pick this up from that one. So yeah, where was it? Control that.
I don't.
Yeah.
Yeah. Is it also not possible you can find the not now, then you subtract from the total? But I think it's a long process.
Yes. Oh, this will be a filter. It doesn't work again. Yeah, quite a long process. But it can work. It will not now and yeah.
Hi, Don.
Hi.
I just wanted you to assist me to explain this code. I'm putting it in the chat box and then you run it. I just want to see what is the difference between the one that you have shared with us. There is the code. I understand the difference is that the one that we've got on line 272 separates the number of missing data in deep delay and also arrival delay, and that one gives the whole the sum as it. Yeah, you can try to run it.
So you see this one, that's the difference. So if I wanted this to work, to answer the question, unless they ask for the total, I'd put something like oh, you can even go a step further and say I bet. Azvikuvhundutse muchiwana nchitsvukisa koti kudai. Okay, there we go.
Okay, hi Don.
Hi.
Inini ndatry kuita like a bit manual. Saka pane code yandaita just now. Saka chiri kundinetsa ndechekuti if like handiti flight delay plus delay handiti.
Mira ndikupe mukana share screen.
It's okay. Kakode kadiki.
Don't worry. Okay. Also nobuka kushare yako. Yeah, taura kwa ndakatiri.
Ndongwaitira time.
Okay.
And just a share screen.
Yeah.
Okay. I can share if you want, but time order. Saka ipane yanda isa izvezvi. Saka like I was trying to add manually because I understand the question is if we want the total of that. Saka now if I and that's for delay and delay. If I put a delay now, it's giving me I used to add that. I mean, can you try it on your machine?
But your code in chat in a one column chat tip delay pana arrival delay.
I want you to see something. It's giving me this output. What's really happening here?
One. This is how you do it. Controls. TD bracket code ya nyaratso. Control V. Control C. Control V. Wait. Now
you see what's happening.
What you are trying to do. Try to add a change in the shape yakadai to something.
Okay. All right.
Is it now making sense?
Yeah.
Now start up with square brackets. What is returned is no longer a series. What is returned is a data frame.
Okay. All right.
I will try to add a two data frame as in a length.
All right. Okay.
Maybe Nyari, for you to work, unobvisa double square brackets, osi apaine one, and then it will come out the way you are expecting it.
Yeah. It. Thanks.
Satisfied? So,
yes.
Okay. Now, missed flights. Up we're looking at all the missed flights. Sagapanema now value. So we are connecting from where this and this is now. 10 rows, 23 columns. 0. Oh, yes. So, this one, It would be something like this. Dokuti buditi. That's how it was worked. I intentionally put the wrong code with that one. I don't worry but we now know how to do it, right? Oh yeah, this is not counting. Oh, kana takada kuti ive iri a data frame. Retain only parts where there are missing values in this column and this column. This is what we can do. Flight. And let me go with the O operate. Did you see what I did there?
No. May you kindly explain?
Okay. Up and I'm going to join two codes. I used this is an O operator. O. That's what that pipe is. So, Natimuna flights take only rows where departure delay is now. O, take rows where arrival delay is now. So I know the woods all rows where either this or this is now. Am I making sense?
Yes.
Okay. So it's the same syntax at Ngachishandisa. But how you can do it using multiple conditions. But with pandas, you are not limited to just one condition. Could it have parent?
Yeah, it's a good reason.
Okay. Where departure delay is now. Yeah. I still need to explain this. But if you want to demonstrate here, I'm going to mabata. You know what is not facts. So, this is another long way of doing it. So what happened here was munatanga ona flight delay.is now. Dokuya kuno dokunotarisa shape yacho. Dokubvaita flights arrival delay.is now. Wotarisa shape yacho. Then kanogada shiri 2. You can add them like this.
I've got a question. What's the point yeku add shape up? Because I understand kuti now values are not one column. I don't want to add both are in the same row. So if we add, I mean, it's not mislead in terms of my row numbers. My rows are not china.
That's true. Saka, inenga could duplicate a kueringa kwacho. You are right. Because it's so duplicate. But in an instance, once we all count how many records are missing. So upon a missing departure delay, it's a missing record. Upon a missing arrival delay, it could be a missing record. So it then depends with the objective your task you want to accomplish. But yeah, that's a good point.
Was I wanted to check now, maybe a scenario you could like in this case we have my columns are actually my different totals and for my missing rows. So one situation of data set and did it. So does it always mean kuti my records in a more missing records though the total number of records of rows are missing? Can I could have another way you could check the total number of missing records combine two rows or maybe those I think that what you know how do you go about it? I mean that's really clear. And well, I think to put it in 2 columns is undated. So it's not always the case. In this case, our deep delay and it then 13 something, 1,300 something. So it's not always putting though the total number of missing records in the manga data sets. It's not gonna pane record. Deep delay is missing, then the other one is available, then it's also seen out. But in this case, I could eliminate my records as and either the total number of records is and either column E and the other one are missing because it's not always good.
Yeah. Saka kana one either this one or that one. Dopa uno gona kuwa eta. However, that it depends on the task. But it's just good practice. Kututangi wawa wona separately. No gonna very missing to deep delay. Asisiri missing for arrival delay. So good for no so ita total no so onati wakawa tarisa uku. Not the number of rows and my missing values. Anenge akato wanda.
So the solution is kind of one by one. You first do the one, you get the total, then you also total the anangasara ash.
Otarisa asara ash. Not it's good to choose this column, this specific column in a cut, this specific column in a cut. So it then depends on the nature of your task. So
okay.
So it all depends on what you're trying to accomplish.
All right, thanks.
Okay. So I think find the number of missing values in each column. You should have it. As you can see, panapa to count apa or one of my counts akasiana. Pamapane 100,000, pamapane 98,000, pamapane chichi. So I find the number of missing values in each column. Yeah, ndori nakana need yekuti vanhu share screen. How do we do it?
Yeah, tamboita kumsoroko.
Exactly.
So you just use the is now somewhere yacho saka inolista macolumns esanonga missing.
Saka muri kubata. Saka muri kubata. So you see. Then upper truquita dot mean. Mean gives us the minimum in each column.
Sorry, John. The question is saying that we should find the number of non-missing values in each column.
Oh, my bad.
Yes.
So this would then be the minimum, not mean. Then can you see something, Panap? Or not mean? Even in a numeric, in a alphabetical characters, in a string, not on a minimum based on alphabetical order. W are not Angira X. And becomes the minimum.
Sorry, the question comes from Bichana. Apata check my columns and missing values and data. And the data set recognition is 100,000 records.
Yeah.
So what happens if not deep time up, partial time up by less than 100,000 when you are looking at non-missing values?
These are the values that are exist. Anything up to 100,000.
Or non-missing in each column, or it's okay. That's also yeah, thanks.
I don't.
Still on that question, can we just call the count, since by default it searches for non-null values without using not null then sum? Can we just use directly the count?
Let's go and see what happens. Exactly. It works. Note count uses non-missing values. I now like the fact that you are now seeing many ways of killing a cat. Okay, so we good?
Yes.
Okay. So mean computes the minimum. Opposite here is max. We can group by a particular variable, then compute a statistic for each of the categories. So we group by unique carrier. Touch one at the average departure delay for each carrier. So for WN, it's 10 hours, I'd like to think. For XE, it's 8 hours. Is this making sense? Goodbye. I remember it was covered not talk yesterday. You remembered?
Yeah.
Yes. So the variation inouya up. Sometimes you do not want to compute a single statistic. You want to compute 3, 5, 4, 6 different statistics for a particular variable. So you use this aggregate function. Then Mukati will specify all the statistics you want to compute. It's computing the mean, the minimum, the average, and the maximum. You can even choose for each variable, what is it you want to compute? For departure delay to go the I. And don't mind this is the same as this. Unique area tangoti the number of unique elements. Do I need to explain more on this?
Maybe John, just to ask, any unique is it an inbuilt function for number of unique items?
Yes, in pandas. We can do this. It's a unique item in pandas. Not necessarily.
Okay, so you know what? And maybe it's because you have coincide ne column name yedu inonzi unique carrier saka tafundzira kuti pati unique saka takuti kuti pana departure delay togona kuti any dp delay whether toburitsa nhamo.
Okay. No, it's inbuilt in pandas like this. So you can do it for any how put it up. Where was I? Yeah.
Sorry, John.
Yes.
Pane question yambovunzwa na Christia yekuti if mna departure delay na arrival or whatever, kana no values they won't be like matching. Can we use the union function so that we get the total number of matching on both colors?
Yes, that's why I used O instead of and. And is intersection, O is union, right?
All right, thank you.
You're welcome. So, as I was saying, it's not gonna apply. Someone contains one unique item. Interesting. So this is computing my descriptive statistics using the dot describe. You remember Pioneers Europe and later out this dot notation. If your column names do not have spaces, you can either use this or the square bracket. Mucharangarira nchiftaura nesoro.
Yes, we remember.
Yes, we do.
Uti. This and this are the exact same thing. Dot deep delay negusa mask web. You can choose either. And watch slice at a frame. This only works kana column name rako ichina maspace kana pani maspace ashandi. So we together.
Yeah, we get you. Thank you.
Yes, we're together.
Okay. Then, what this IDX mean does is enokupa the index of the minimum value. Again. More data set. What I'm talking about is if I do this, this is the minimum departure delay, meaning that you play in yakakurumbisa in 44 minutes. A negative 44. That's the minimum delay, right? However, ndoda kuishandisa mcode mangu kuti ndinoona kuti iri papi chaipo chaipo. I can slice using this. So this is the index and I'm gonna slice. In this column, ndokuda pa row here, I get that minimum value. Index of the minimum. Its opposite is index of the maximum, IDX max. Like this. My bad. Do you understand this?
Yes.
Yeah.
Value counts, as the name suggests. It counts how many values of a particular type or category exist in a column. So I'm column as unique carrier. We have 94,000 WN, 5,900 XE. So this returns a series. Ndoya yandaitaura kuti kana wada kudrowa ko pie chart rako. Complete format. Plot. So it's the auto percent argument. And error. Let me think. It's for imputing percentage. Oh yeah. It's for imputing percentage on your item. My bad. So that's the nice thing you could return error series Majwana. With the series you can then plot. Uzozviona yenyu pazvinoshanda kana makuzoita madissertation yenyu. No, chapter 4 is all about plots and whatnot. And sometimes when you want to visualize the results of your analysis. Muri kumabasa ikoko. Plot kind equals to pi. You can see how it's distributed.
Sorry, John.
Yes.
I think I might have missed it on the last lecture. The autopacity percentage .2 F, what does that? What is it for?
Compute the percentage to 2 decimal places.
Okay, thank you so much.
Point 2. Makes sense? This is the legend.
I put in the whole code, Mangoisa, just the way you did, but it's giving me an error. Whole plot.legend. Let me try.
Okay, there we go. Ndaisa mchat. Code yandashandisa. Then yepazasi pacho. Ndaisa futhi mchat.
Hi, Don.
Hi. Yes.
Do I put percent sign on the pie chart?
Percent sign. Yeah, you put 2 percentages at the end. Voila.
Or how about if you want to save that any chart to a picture?
It should save. Let me check. Yeah. Yeah, it was safe. I'm full that I'm putting a notebook.
Okay, thanks.
Okay. However, I got carried away. The gist of this one, when the electoral value counts, gives you a number of occurrences of a particular category in a column. Then plt.hist. Remember, Nezuro we were plotting directly from pandas. So I'm going to df salary.hist. You go to plotter. The other notation, the E, where we are using matplotlib instead of using the input fashion and pandas. So I guess what you have to take note of, Pana, is fixed size out is the You now take it from plt dot figure. Am I making sense? So you can then put various labels, X label, Y label, SRM on PLT mom. This is a dist plot. Yesipon. Yesipon nopya kuikira ka kernel density plot kacho. You see, it's the same thing. But if I was sipon in that. But I'm indifferent to the two. Whichever gets the job done.
Sorry, so are you saying kuti matrix ari kusibon tinomaona kumatplotlib kana kuti kuzoisa sibon pane mamwe panenge functionality inenge isipo mumatplotlib?
Okay. Right. Inenge irimo. Asi inenge iri difficult kuita. Kore kumatplotlib. Okay, let me think.
Okay.
Right. Let's assume distribution shangawanish in my range. Sipon is a U argument. Yakut I can then add. Okay. Right. Yeah, right. F dot head. salary and service. Okay, this session. Oh, it's X and Y. Let me put, what can I use as my X? X and Y. My bad. So one thing you realize is Seaborn is also built on top of Matplotlib. So let me get rid of this. Can you see this? It's also built on top of Matplotlib. Get rid of that. So you see, added capability Seaborn. It's now easier for me to compute my categorical variable akasiyana, to include a categorical variable in one plot. Compared, if I was gonna try to do it with using Matplotlib, I was gonna need 3, 4, or even 5 lines of code. But Seaborn, in one. You can see the distribution of salary across rank by gender. 3 items visualized at once.
Yes, Don.
Okay. Is your question answered pertaining to Seaborn and Matplotlib?
Yeah, it's answered. Yes.
Okay.
Can you just go back to the one that we're doing?
This one?
Yes, that one. Okay, it's fine.
Do you want better? I'll paste it in the chat.
Yes. I've taken a picture.
Okay. And I set the code in the chat as well.
I don't. Is it possible you could show us how you could achieve the same using Matplotlib?
Yeah. Okay. What did I do? Let me see. Let me try to figure it out. I'm generally a lazy guy. So if I find something easy, an easier way, I normally stick to it. So, matplotlib, I have, yeah. What? Oh. Oh boy. So, first challenge I'll encounter is with matplotlib, I don't have prequisa y, right? I don't have an argument for y. So that naturally, yeah.
I think
Okay.
if it will take long, we can move on. I was just curious.
So,
I ran your code, but I'm getting an error. The exact same one that you pasted in the chat box. So I'm not sure.
share your screen.
Okay. This one. Can you see? And this one as well.
Okay. Right, in that instance, name df is not defined. What that means is you closed your notebook since yesterday, right?
Yes, but this one is the
The variables that can define my variables that can define as zero. They are probably not working on yours. Run or run it from the top.
Oh, okay. So I run it.
Define it.
Okay.
Run from what cannot define a TF.
All right. This one was working, so maybe I continue from this part, from the pie chart part. Okay. Thank you.
So that's a good TF. Yeah. Okay. You're welcome.
TF.
Okay, so let me share my screen again.
I don't. Can you share the salaries.csv?
It's already in the folder where you got the pandas. Salary CSV is the same CSV from yesterday. So if both your notebooks, or if they're in the same folder, then you have no problem. If they're in different folders, go and copy salaries CSV, or paste it in today's folder, then everything will run. Here is one. Meaning I would have to filter out those are remaining again. Only the salaries data frame. Salaries nearing agent. Dokuti item yangu ibudi. PLT dot box. X equals to. So in order to use it, ne matplotlib, I would have to filter produce and notched. Vertical whisker. Oh, that's the calculation for the outliers. Bootstrap. Confidence interval positions with labels. I would have to draw a single one, each in a different position. Kuti no border. Kuti izobuda yakaningirikena. What am I trying to accomplish? It becomes by object. It would take longer than I thought, unfortunately. So I'll just move on. And then that's what I box plot of this. Still not showing me what I want. So I would need to restructure my data in a complicated way. Unfortunately, time will not permit us. So generally, when you are using Matplotlib, no panoseita limitation. You can only apply it when your data is in some type of format. Then SIPON was now designed putting a social data frame. That's why it's easier to accomplish this using SIPON. Here we're doing a bar plot of the salary. It's the same as this one. X rank, Y salary, estimator, length. You can then view it by sex. This is a violin plot. In Engage Kurat, it's a salary. So what we're working with here is, most people earn around this much. So this is called a violin plot. I'm sure you can tell why. This is a joint plot. A joint plot gives you a scatter plot of two different variables, as well as the distribution of those variables. You see, salary kunoko. 100,000 patach one apaka one. You can see it here. So this is a histogram of the salary. A histogram here was this variable service. And this is a scatter plot of the two. So it's called a joint plot. A code you already have it in the notebook. Then this regression plot, a scatter plot, and in addition it gives you what do you call it? A line of best fit. CI is 95, meaning it's in a confidence interval 95%. This is what you see. Shaded blue line. We have drawn the similar plot, but the only difference is what visa U. This time they have added the U. This is a SWAM plot. The right-hand box plot is also used for plotting categorical data or now the distribution of continuous variables across categorical data. Or not my prof and one my salary associate prof, etc. So this is a factor plot. Deep delay, unique carrier. Sort of like a bar plot in an again. A bar plot. It's all outlier. That's the factor plot, CMC one. And this is a pair plot. So what a pair plot does is, instead of plotting my numeric variables one by one, or how they correlate, could draw a plot.
Sorry, Don.
Yes.
In the previous line, may you kindly repeat? I'm lost. My code is not on my notebook.
Really?
Okay. If you can just scroll up. Line 26.
Okay.
216 or 215. Line 216.
What's the
I don't have that graph. That error where on line 216, I also have it like it's showing on yours. That
it's not an error.
What
it's a warning. It's a warning.
Okay, maybe can you paste the code in the chat? So maybe I use that one.
Okay.
Don't say to get rid of the error, just put PAT.show.
This is just a warning, which is telling you that the factor plot, right? It's also known. It does the exact same thing as what is called a cat plot, right? So it's advising you that in a future release, factor plot, that function will be deprecated. It will no longer work. What will be now working is a factor plot. I know kare yakudza in advance kuti tusazongomuka one day waupdata siponi yako utozoshamisika kuti maiwe zvinhu zvangu hazvisi kurana.
Okay. Thank you.
Okay. So, okay. Yeah, thanks for taking note of that. So that's the beauty of it.
Yeah, and I akangochinja code yake pana factor plus akasa cat plot inobva yabuditsa on the same graph but isina warning.
Exactly. All right. Okay. Thank you.
That's the beauty of attending lectures. No. Little stuff. Inonetsa kuti munhu uise yese manotsi. So, having done this, we have a pair plot. As the name suggests, it pairs two variables. Yokubuditsira scatter plot for each variable. You see panapa pamsoro PhD salary service. Kunoku PhD salary service. So where PhD and PhD intersect tunopiwa a histogram. Where PhD intersects with salary tunopiwa the scatter plot. Where PhD intersects with service tunopiwa a scatter plot. This is highly correlated. Can you see? Where salary and PhD, you see those two are identical. Then salary and salary histogram. Salary and service scatter plot. Chingodaro. So here's an exercise. Don't worry, takutopedza guys. Pangosara zvidiki. Exercise using Seaborn package, the SNS ELEI. Explore the dependency of arrival delay on departure delay. Use a scatter plot or a regression plot, not the rate plot. How long would you need to do this? It's just of code, guys.
They need 2 minutes, no? My experts just need 2 minutes.
2 minutes. That's right, Doc.
2 minutes.
So 2 minutes, guys. So guys, anyone to present?
Can you see it? Sorry.
Yes.
Add delay and
oh, that's good.
It's add delay and sorry. It's DEP.
Capital D.
Capital D, okay.
DEP. Then capital D again. Impressive. Is this stuff right, guys? Sonia, can you do the same using a regression plot?
Okay.
Mm-hmm. Ah, nice. Okay. So can you see how easy it is, guys?
Yeah, Don, it looks okay in terms of plotting the graphs, but now, my eyes were trying to interpret, especially where those dots are merged around each other, that kind of a thing.
Yeah, that would mean where the dots are clustered around each other. As you can see, the plot generally is departure delay increases, arrival delay increases. They are highly correlated. So where they are matched around each other, those are the times where delay normally occurs. The amounts where delay usually occurs. So it's like, I think it's rare for delay to happen for like 400 or 500. I don't know what unit of measurement they were using. However, between 0 and 300, that's quite common. Maybe it's minutes or it's seconds. I don't know, but this, where it's matched, it means those are very common occurrences. Then on the side of arrival delay, the same can be said. That's why they are clustered together that closely. There are many occurrences around that time period. Are you answered?
Yes, thank you very much.
Okay. Then, now, isn't it you're doing statistical analytics? Statistical analysis.
Yes, we are.
Yes. Which package are you using? Starter?
R.
Yeah. So, what you can do in R, you can also do it in Python using the stats model API. So, in this instance, we're doing a normal linear regression model using, that ordinary least squares method, the one you use in your statistical analysis. So, linear model equals to OLS.
Sorry, John, you are not sharing your screen.
Oh, my bad.